Hi, today I will be going over 4.9 for Algebra 2, which is graph and solve quadratic inequalities. So the steps to graphing quadratic inequalities is to first graph the parabola, decide if it's a solid or dashed line, and use the inequality to determine where to shade. So this is very similar to graphing and shading absolute value and linear equations. All the rules still apply, it's just that it's a parabola instead. Okay, so for our first graph, we have y is less than x squared plus 4x minus 5. So this is in standard form, which means we know the y-intercept right away, which is at 0, negative 5. It's always going to be the c value. So it's right here. And then we want to find the axis of symmetry. So that would be x equals negative b over 2a. So that's negative 4 over 2, which is negative 2. So our axis of symmetry is at x equals negative 2. Okay, now that we have our x-coordinate of the vertex, we want to plug this in to solve for y. So for the vertex, we know it's going to be negative 2 for the x-axis or x coordinate, and we want to plug it in to find y. So we can change it to an equal sign, and it'll be negative 2 squared plus 4 times negative 2 minus 5. So that'll be 4 minus 8 minus 5, which is negative 9. So the vertex is at negative 2, negative 9, which is right here. So it can also reflect the y-intercept. So that would be right here. And then we can estimate the graph. So look, ooh, sorry, that was very wobbly. Okay, there we go. That doesn't look that much better, but a little bit, I guess. Okay, so it looks something like this. Oh, shoot, hold on. Okay. So I had to erase that because I drew a solid line, but there's no equal to sign in the problem, so it's actually a dashed line. Okay, and it says y is less than, so we want where y is smaller, which would be on the outside of the parabola. So it would be all of these points here. Okay, next one, we have y is greater than or equal to negative x squared plus 6x minus 5. So again, since this is in standard form, we know the y-intercept, which is going to be at 0, negative 5, which is right here. Then we'll want to find the axis of symmetry. So that's x equals negative b over 2a. So that's negative 6 over negative 2, which is 3. So then for the vertex, that means our x-coordinate is 3, and we want to plug in 3 for x. So y equals negative 3 squared plus 6 times 3 minus 5. So that's negative 9 plus 18 minus 5. So we get 4. So the vertex is at the point 3, 4, which is here. Our axis of symmetry is here. And this will be a solid line because it's equal to. So it would look like this. And we want where y is greater than, so that would be the outside of the graph, which would be this space here. and that's where you'll want to shade. Okay, this next one, hold on, I'm gonna move this just so it doesn't look like it's part of the problem. Okay, so we have two graphs this time. We have y is greater than or equal to x squared minus 4, and we also have y is less than or equal to negative 2x squared plus 4x minus 5. So let's start with the first one. The y-intercept is going to be at 0, negative 4, and the axis of symmetry is going to be negative 0 over 2 times 1, since there's no b value, so this would be 0. And if we plug in 0, we're going to get negative 4, because it's going to be the same as the y-intercept. So in this problem, the y-intercept and the vertex are the same point. So it's right here. And our axis of symmetry is here. So to find the x-intercepts, we're going to plug in 0 for y. So that'll be 0 equals x squared minus 4. And we can add 4 to both sides. So we get x squared equals 4 and square root both sides. So we get x equals plus minus 2. So those are our x-intercepts. So they look like that, and since this is since y is greater than or equal to, that means it's going to be a solid line. And we would shade inside. So look something like this. Okay, then for the next one, so let me just draw a line so you can tell that this is for the other part. Our y-intercept is 0, negative 5. Oh shoot, sorry, hold on. I was supposed to change this problem. So this should be a plus, and this should be a 1. I think I forgot to edit it before I made it a PDF. Okay, so the y-intercept for the second one is at 0, 1, which is right here. And then we have to find the axis of symmetry. So that's going to be negative 4 over 2 times negative 2, which is negative 4 over negative 4, which is 1. So for this one, the vertical line goes through here. Then we're going to plug in 1 for x to find the y coordinate of the vertex. So we'll get y equals negative 2 times 1 squared plus 4 times 1 plus 1. So that's negative 2 plus 4 plus 1. And that is 3. So our vertex is the point 1, 3. Okay, so we can reflect our y-intercept, which would be here. And then graph. Okay, so since it is equal to, that means we would make a solid line. And for this one, y is less than, so we would be shading inside the graph. So that would be the shading for this. And our final answer would be this area here, because that's where they overlap. Okay, last graphing one, we have y is greater than 3x plus 3x squared plus 3x minus 5. So for this one, we know the y-intercept is at 0, negative 5, which is right here. And then to find the vertex, we have to first find the axis of symmetry, which is going to be negative 3 over 2 times 3. So that's negative 3 over 6, which is negative 1/2. Oh, sorry, I kind of ran out of space. Okay, so then for the vertex, we're going to plug in negative 1/2 in for x. So that'll be y equals 3 times negative 1/2 squared plus 3 times negative 1/2 minus 5. So that's 3 times 1 over 4 minus 3 over 2 minus 5. So that's 3 over 4 minus, I'm going to change all the denominators to 4. So this would be 6 over 4 and that would be 20 over 4, just so it's a little easier to add them. Okay, so then this will give us negative 23 over 4. Okay, so this point is going to be a little less than 8, negative 8. So it'll be somewhere here. And our axis of symmetry goes through, oh, hold on, x is negative 1, sorry. So the point should be somewhere here. And our axis of symmetry goes through here. And we can reflect the y-intercept. Dang, this is gonna look so skinny. Okay, so it's gonna look, y is not equal to, so it's going to be a dashed line. Okay, I feel like I drew this side kind of weird. Okay, and then for the shading, y is greater than, so it would be this inside area here. Okay, so that's for the first graph. For the second one, we're going to do the same thing. So the y-intercept is at 0, 2. So that is right here. Then for the axis of symmetry, that's negative b, which is negative 5 over 2a. So this would be negative 5 over negative 2, which is 5 over 2. So for the vertex, we're going to plug in positive 5 over 2 for x. So then we get y equals negative 5 over 2 squared plus 5 times 5 over 2 plus 2. So that's going to be negative 25 over 4 plus 25 over 2 plus 2. And I want a common denominator of 4, so I'm going to rewrite the other ones. So that's 50 over 4 and 8 over 4. So then we get 33 over 4. And that's going to be a little more than positive 8. So that is, okay, 5 over 2 is 2.5. So it would be somewhere here. And that's our vertex. So now we can reflect the y-intercept. So we want to go 2.5 or 5.5 the other way, so that will get us to 5. So there's going to be our other point. Since the graph is less than or equal to, that means it's going to be a solid line. And we would shade, it says y is less than, so we would shade this area here. So your final answer, or the overlapping part, would only be this part here. Okay, and then the last part of this problem, we're going to solve quadratic inequalities by using a number line. So first you'll want to solve by x by factoring if you can. Then you'll create a number line and test numbers in each interval, and then write the final answer as an inequality. So for this first one, we have 4x squared is less than 25. So we want to isolate x, and we'll get x squared is less than 25 over 4. Then to get the x by itself, we're going to square root both sides. And then this is where I'll just switch the inequality sign to an equal sign, because it doesn't make sense to write x is less than plus minus 25 over 4. Oops, I mean 5 over 2, because that's the square root of each. Okay, so now that I solved for x, I'm going to draw a number line. So I have negative 5 over 2 here and 5 over 2 here. And I'm going to test numbers to see if they work for the inequality. So when it's between here, I always like plugging in 0 because that's super easy. So we would get 4 times 0 squared is less than 25, which is true. So that means this would work. Now we'll also have to find one in this section. So it has to be a number where x is greater than 5 over 2. So I'll pick 3. If I plug in 3 into the equation, I would get 4 times 3 squared. 3 squared is 9, so 4 times 9 is 36. And 36 is not less than 25, so that side doesn't work. And then for the left, I would plug in negative 3, and this again would get you 36, so this one would not work either. So the final answer would be any number between negative 5 over 2 and positive 5 over 2. And we would not change the problem to equal to. So since the original problem did not have an equal to part, we're going to keep it without. Okay, here is the next one. So first we're going to add 28 to both sides. So we get x squared minus 11x plus 28 is greater than or equal to 0. Then I'm going to factor, or I'm going to see if I can factor. So if I do the x method, on the top would be 28, on the bottom would be negative 11. So that would be negative 7 and negative 4. So this would factor into x minus 7 times x minus 4 equals 0. Then I'm going to set each one equal to 0. And solve. So I'll get x equals 7 and 4. Okay, so again, draw a number line. We have 4 here and 7 here. And we're going to test numbers in each interval. So on the left, I'm going to try x equals 0. So then I'll get 0 minus 0 is greater than or equal to negative 28, which is true. For the middle, you can really test any number, but I'll just choose 5. So 5 squared is 25 minus 11 times 5, which is 55. So we have 25 minus 55, which is negative 30. And negative 30 is not greater than or equal to negative 28. So it would not work here. And for the right hand side, I could choose like x equals 8 or 9, but I just chose 10 because it's an easy number to work with. So I would get 10 squared, which is 100 minus 11 times 10, is greater than or equal to negative 28. So that's 100 minus 110 is greater than or equal to negative 28. So that's negative 10 is greater than or equal to negative 28, which is true. So my answer would be x is less than or equal to 4, because that was where the solutions worked, or x is greater than or equal to 7. And in blue here, I just did some of the work, but if you want to do that in your head, that's fine too. Okay, number 7. So we're going to see if we can factor this one. On the top would be negative 6, on the bottom would be negative 5, and that would be negative 6 and 1. So this would simplify to x over negative 3. So then we get x minus 3 times 2x plus 1 equals 0. So we're going to set each one equal to 0. And we'll get x equals 3. And negative 1/2. So then from here, we're going to draw our number line. We have negative 1/2 somewhere over here, and then 3 over here. Okay, so I usually start with wherever x equals 0 first. That's just my personal preference, just because it doesn't take that much to think about. But if you want, you can just like work left to right. Okay, so if we plug in 0, we would get negative 3 is less than or equal to 0, which is true. On the left, I would plug in negative 1. If I did that, that would be 5 times negative 1 minus 3 is less than or equal to 0. So that's negative 2 plus 5 minus 3 is less than or equal to 0. Wait, did I do something wrong? Because this does equal 0. Okay, I feel like I did something wrong, but I'm not sure what. Okay, let's try a different number instead. Okay, let's try negative 2. So that would be 2 times negative 2 squared minus 5 times negative 2 minus 3. So that's 2 times 4 plus 10 minus 3. So that's 8 plus 10 minus 3 is less than or equal to 0, which is not true. So that means this doesn't work. Okay, then for the last part, I would plug in x equals 5. So that'll be 2 times 25, because that's what 5 squared is, minus 5 times 5 minus 3 is less than or equal to 0. So that'll be 50 minus 25 minus 3 is less than or equal to 0. And then that would be 22, which means it does not work. So that means our answers would have to be between negative 1/2 and 3. Oops. And our signs would be equal to, because the original problem was equal to. Okay, next one we have negative 4x minus x plus 3 is less than or equal to 0. So when factoring, we always want to take out the negative first. So that'll be 4x squared plus x minus 3 is less than or equal to 0. And we can divide everything by the negative 1. So we'll get 4x squared plus x minus 3 is greater than or equal to 0. Then we're going to factor. So on the top is -12, on the bottom is 1. So the two numbers that will multiply to -12 and add to 1 would be 4 and -3. So this simplifies to x over 1. So that becomes x plus 1 times 4x minus 3 equals 0. So we're going to set each one equal to 0. So we'll get -1 and 3 over 4. Okay, on the number line, here's -1, and here's 3 over 4. So if we plug in 0, we would get 3 is less than or equal to 0, which does not work. If we plug in -2, we would get -4 times 4 minus -2 plus 3. So that's -16 plus 2 plus 3 is less than or equal to 0. That's going to be -11. So that works. And we could plug in 1. So that would be -4 minus 1 plus 3, which is also less than 0. So that works as well. Okay, so then that means our answer is x is less than or equal to -1, or x is greater than or equal to sorry, this should be positive. Positive 3 over 4. Okay, next we have -3x squared plus 10x is greater than -2. So I'm going to first add 2 to both sides. So we get -3x squared plus 10x plus 2 is greater than 0. We want a to be 1. A to be positive, so I'm going to factor out the negative. And then I'm going to divide by -1 to get rid of the negative. So 3x squared plus 10x minus 2 is less than 0. Okay, so if I try to factor, the top would be -6 and the bottom would be 10. So we would be looking for two numbers that multiply to -6 and add to 10, but none of those numbers exist. So we can't use factoring. We could use the quadratic equation. And the quadratic equation always works. It's just that it's kind of tedious. It takes a while to solve. So if we plug it in, we'll get, oh, oops. This should be a minus. Okay, so we'll get 10 plus minus -10 squared minus 4 times 3 times -2. Oops. Over 2a. Okay, I'm going to simplify some things on the calculator, so I'm not going to write every single step because it just takes up a lot of space. And I don't have that much space. Okay, so inside would be 116 over 6. And 116 would break up into 2 and 58. And 58 breaks up into 2 and 29. So we can take this out. This would be left on the inside. So we get x equals 10 plus minus 2 rad 29 over 6. And we can simplify this to 5 plus minus rad 29 over 3. Okay, so we're still going to draw a number line, but I would just plug in the numbers into a calculator. The one that's always on the left is going to be the minus one, so 5 minus rad 29 over 3, and the one on the right will always be the plus one. Oh wait, actually, that's not true. It depends on what sign's in the front. But yeah, I would just plug in these numbers into a calculator. So if you do that, you'll get about negative 0.13 and 3.46. So you'll want to plug in numbers again. I'm going to plug in 0. If I do that in my original equation, I'll get 0 is greater than negative 2, which works. Over here, I would plug in x equals negative 1. So that would be negative 3 times negative 1 squared plus 10 times negative 1 is greater than negative 2. So that's negative 3 minus 10 is greater than negative 2, which is not true. And then for the last section, I will plug in x equals 4. So that'll be negative 3 times 16 plus 10 times 4. So that would be negative 48 plus 40 is greater than or equal to 0, which is not true, so it doesn't work there. Okay, so that means our answer is between 5 minus rad 29 over 3 and 5 plus rad 29 over 3. And it's not going to be equal to because our problem wasn't equal to. Okay, last one. So we have 3x squared plus 1 is less than 15x. So we're going to subtract 15x on both sides first. So we get 3x squared minus 15x plus 1 is less than 0. If we try factoring, on the top would be 3 and on the bottom would be negative 15. So that means we're looking for two numbers that multiply to 3 and add to negative 15. And there aren't any because the only numbers that will multiply to 3 are 1 and 3 or negative 1 and negative 3. So that means we have to solve by quadratic again. So a is 3, b is negative 15, and c is 1. So when we plug this in, we'll get 15 plus minus square root of negative 15 squared minus 4 times 3 times 1 over 2 times 3. So that's going to simplify to 15 plus minus rad 213 over 6. And 213, oh, it does simplify. Let's see. So it's divisible by 3, and that would be 71, but 71 is prime. So we can't really change this number. Okay, so we would draw our number line. So we have 15 minus square root of 213 over 6, which is about 0.068. And we have 15 plus square root of 213 over 6, which is about 4.9. Okay, so I'm going to plug in 0. I would get 1 is less than 0, which is not true. And I'm plugging this into the original equation, by the way. Okay, then I would plug in x, I would plug in x equals negative 1. So it'll be 3 times negative 1 plus 1 is less than 15 times negative 1. So that would be negative 3, that would be 3 plus 1 is less than negative 15. Oh shoot, sorry. 0 is not in between here. 0 is here. My bad. Okay. 0 is in between 0.068 and 4.9. So it didn't work here. Okay, so here we could plug in 1, since that would be between 0.068 and 4.9. Okay, so that'll be 3 times 1 squared plus 1 is less than 15 times 1. So that's 3 plus 1 is less than 15, which is true. And then for the last one, I'll plug in x equals 5. So that would be 3 times 5 squared plus 1 is less than 15 times 5. So that's 3 times 25 plus 1 is less than 75. So 75 plus 1 is 75. So this is not true. So our answer is going to be between 15 minus rad 23 over 6 and 15 plus rad 25 over 6. And our original problem wasn't equal to. Okay, so that's it. Sorry, there were some places I kind of messed up, but hopefully this section isn't too bad. It's just figuring out numbers to plug in. Okay, thank you so much